So welcome to the third video in the Jerboa tutorial series, just going over an example workflow here. In the previous video, I went over the slab program. I also, in the video before that, I went over the installation process, which is very simple. Just something a little finicky with EnergyPlus. Here, we're taking a look at the basement program. And if you watch the slab program, it's essentially extremely similar. Here, we don't need to run this again. If you've already run this, it's just here at the top of the program for safekeeping, if you will, even though you can find it here under the utility tab. So in the basement program, very similar to the slab program, we have a material info component and a building info component. Similar to the slab program, there are a lot of possible inputs here. I have provided and given some sort of reasonable defaults to this. So if you're looking for something that is better than nothing, but not the most accurate, then these should do, though, by all means, feel free to go through and input these things. The same is true for the basement building info component here. So, the material is fairly straightforward. In terms of the basement building info, we're basically looking at wall thicknesses, slab thicknesses. We're also looking at the kind of qualities and characteristics of the gravel next to and beside and below the basement walls and slab. The other thing that's important to consider here is whether the zone is conditioned. So if this is like a crawl space, or if it's an occupiable basement. The depth of the basement will have an impact on the amount of heat transfer happening through the basement walls, obviously, and increase the surface area of the basement walls. The area to perimeter ratio is important in this case. So, if you have I guess it'd be a somewhat smaller area to perimeter ratio where you have that kind of a smaller building, that sort of becomes quite important. And then, of course, we have the heat temp and cool temp, where if I plug in a panel here, the cooling months are from May up into September, and the heating months are from October to the following April. If you want to change that, feel free to dig into the code in this component. So taking these components, feeding them into their respective inputs on the run basement, the run basement component looks very similar to the slab component. We have the base folder name, we have the folder we want to save and work out of on our little process in the run basement program here. We have our input for our EPW, which should be looking, yeah, okay, good. So this is looking for the EPW next to your Grasshopper file. I'm copying the EPW into this new folder, and I'm making the directory, I'm writing that directory, and then all that's left to do, all these booleans are set to true. All that's left to do now is this is just a warning. Sorry, I was concerned for a moment. This is just warning that there's no output yet. Is press run. So this will open a command prompt, and it'll run the basement program. Now this will take a little bit of time. So basically what this is doing is running through a series of iterations I believe in the run basement component, I've set the convergence, the max delta T, which sort of qualifies whether the solution has converged, to 0.1. So this is basically going to run through a series of iterations to try and converge on a solution. For me, this usually takes anywhere from 10 to 15 minutes. So I'll come back when it's looking like it's going to be done. Okay, so that just worked. And I tried to start the recording again right as it was finishing, so you know what to look for. But I did manage to start it and finish right away. So it took, I think it took about 300 seconds. So actually, you know, faster than what I was saying of 10 minutes. Although just be aware that it can take it can take longer than 5 minutes, but five to 10 minutes, I would say. And what we're given here are 3 outputs, and there are a couple others, other outputs that come with this basement program that you can find in this file here, in the folder here that you specified. But the 3 of interest are the IDF, and this is the path to that IDF. Also, CSV that is has basically all the temperatures embedded in it, and you can find references for that on Big Ladder or EnergyPlus. And then finally, the thing that's most of interest is the ground temperatures. So I'll just put this up here. So the basement program, the run basement component outputs, again, a ground temperature building surface string that can very conveniently and easily be input into the Honeybee Model 2 OSM component. So it's really as easy as that. You get your ground temperatures, and you then can feed them directly into your model in Honeybee. Of course, alternatively, if you're using another climate modeling software like Climate Studio, you can very easily input these temperatures into either the GUI, or if you're using a Grasshopper interface with Climate Studio, you can input it that way as well. And so that is the basement program. I'll also mention that in the manual and reference here and documentation, I have just a kind of few steps to make this run and work. And then, of course, further down, kind of references to each of the inputs on each of these components, and their units and the type of input they're looking for, because I know that that's sometimes not super clear.